7. Today we're going to start chapter 8, and the title of the whole chapter is Exponential Functions. So we're going to be exploring this equation, y equals b to the x. That x is in the exponent position. That's why it's called an exponential function. So we're going to be answering the question, what do those exponential graphs look like? And question 8.1 says, beginning to investigate exponentials. So linear functions are y equals mx plus b. Their graphs look like lines. Today we will look more closely at the y equals b to the x function. So the two different types are increasing functions, like when we have the rabbit situation. It's going to start growing really slowly, and then all of a sudden it's going to grow really fast. And then the decreasing function, like the bouncing ball, it's going to bounce really big, and then it's going to start getting less of a bounce real quick. So that's a decreasing exponential function. All right, so down at the bottom, we're going to start by graphing the following functions. So what you're going to do is you're going to take the number that's in the first column, and you're going to plug it in for that little exponent x that's right there. It's kind of even hard to see. That means you're going to take this -1, and you're going to have 2 to the power of -1. When you have a negative exponent, that negative exponent moves the number from the numerator to the denominator, and it becomes 1/2. So in this box, you're going to fill in 1/2. Then when you plug in a 0, you have 2 to the exponent, or 2 to the power of 0. Anything to the power of 0 is 1. So you're going to fill in a 1. Now we're going to plug in a 1. So 2 to the first power is just 2. And then when you plug in a 2, you have 2 to the second power, which is just 4. And then when you plug in a 3, you have 2 to the third power, which is 8. Okay? Once you have your chart all filled out, then you can work on your graph. Okay, so the first point is at -1, 1/2. That means from the origin right here, you're going to go 1 to the left and then up halfway and put a point. For the point 0, 1, you're not going to go any right or left. Then you're going to go up 1 and you're going to put a point. Then for the point 1, 2, you're going to go 1 to the right, up 2, and put a point. And then for the 3, you're going to go 3 to the right, up 8, and put a point. You'll see that your graph grows really slowly, and then it's going to grow really fast. Did it make a line? Nope. Definitely not a line. Okay, that's more of a curve, a smooth curve. Okay? For the next box. For the next box, we're going to simply take all the numbers that we had in box A, and the only thing that's different is there's a negative sign out front. So that means that you're going to take the opposite, or the negative, of all of the answers we got in the column over here. So we got 1/2 becomes -1/2. We got 1 becomes -1. 2 to -2. 4 to -4. 8 to -8. Everything just switches to the negative sign. Okay? So when you graph it, instead of your smooth curve going up, you're going to have a smooth curve going down. Okay? Then in the third box, the base is going to change to 1/2. Okay? So when you take 1/2 to the -3rd power, that denominator is going to move to the numerator and go to the +3rd power. So 2 to the 3rd power is 8. Then we're going to plug in a -2. So 1/2 to the -2nd power. That 2 moves to the numerator, and the exponent becomes positive. So 2 squared is 4. Now we're going to plug in a -1. So the 2 is going to move up to the numerator. The exponent is going to become positive. You have 2 to the first, which is just 2. Then we're going to plug in a 0. Anything to the 0 power is always 1. And we have 1/2 to the first power. It's just 1/2. So on this one, when you go to graph it, it has a decreasing smooth curve. Okay? So each of the points you're going to plot on your graph. Then we're going to skip page 2 for right now. We'll come back to it in a second. And you're just going to go straight to page 3. Okay? All the way over to page 3. The top of page 3, we're doing question 8-3. It says the graph of the function y equals 1/2 x is shown at right. We just did it right here in C. So that looks the same as this one right here. There's just a decreasing exponential function. And the question says to describe what happens to the y as the x gets larger and larger. So if you look down at this graph, what happens right here? What does it look like it's about to do? It looks like it's getting really, really close, which it is, but it's never going to cross. It's just going to get closer and closer and closer, but it's never going to cross. So here's what you're going to write. You're going to say that the y is going to get closer and closer to 0. Okay? Closer and closer to 0. Right? Part B says, does the graph of y equals 1/2 to the power of x have an x-intercept? Is it ever going to cross? The answer is no, it does not have an x-intercept. It's going to get closer and closer, but it's never going to cross. Okay? Part C, when x is very large, the graph of y equals 1/2 to the power of x approaches the x-axis. That is, as x gets larger and larger, farther to the right along the curve gets closer and closer to the x-axis. In this situation, the x-axis is called an asymptote of y equals 1/2 to the power of x. You can read more about asymptotes in the math notes box in this lesson. Does y equals 1/2 to the power of x have a vertical asymptote? In other words, is there a vertical line that the graph above is going to approach? So we have this horizontal asymptote. It's going to get really close to that x-axis. But do we have a vertical one that's going up and down? A line that the graph is approaching. It looks like it's going to have one right here. But as this graph gets bigger and bigger, because it won't fit on this page, you made it to positive infinity, you would get larger and larger. So the answer is that no, there is no vertical asymptote for this graph. Okay? We're going to read the math notes box down at the bottom. And let's see, who do we have today? So the first paragraph. Where's Andrew? This first paragraph right here, a mathematically. Awesome, thank you. So you'll notice that the dashed lines are technically not part of the graph. They're what we call the asymptotes. They're imaginary lines that are blocking the graph from passing a certain point. Okay, so this graph has two asymptotes, one at y equals 3 and one at x equals 2. This one has one at x equals 5. This one has one that's a curve, or what we call a parabola. And then this one has a slanted line at y equals x. Okay, so the dashed lines are not technically part of the graph. They're just, think of it as the barrier, the line that the graph can't pass. Okay, the next paragraph right here with starts with as, that would be writer.
As you can see in the examples above, asymptotes can be diagonal lines or even curves. However, in this course, asymptotes will almost always be horizontal or vertical lines. The graph of a function that has a horizontal asymptote. If, as you trace along the graph out to the left or right, that is, as you choose, x coordinates farther and farther away from zero, either toward infinity or toward negative infinity.
Are you done?
No.
Oh.
The distance between the graph of the function and the asymptotes get closer to zero.
Okay, awesome, great, thank you, good job. All right, last paragraph, Jordan.
The graph has a vertical
Asymptote.
If, as you choose, x coordinates closer to a certain value from the left or right, so y coordinate gets farther away from zero, either towards infinity or towards negative infinity.
Awesome, great job, thank you. All right, so now you're going to turn back one page to page 2. And here's page 2, which is investigating part 1. So it says your task with your team, you're going to try different values of B to find as many different looking graphs as possible. You're going to stick to the smaller values between -10 and +10. And you're going to keep your window kind of small, okay? Mostly because these graphs right here are just from -10 to +10. So if it's way off, then pick a different number. Decide as a team what different values of B you can try so that you can find as many different looking graphs as possible. And you're going to use your E tool. So when I'm done talking, you're going to go on your Chromebook. You're going to log into your textbook. And then you're going to go to chapter 8, the very first lesson in chapter 8. And then you're going to scroll down until you get the E tool. The E tool is going to have a slide for you to use. So with your pointer, you're going to grab it, drag it across until you find one that you like, that you can draw on here. And then you're going to write down what number it is. So let's say you pick 7 to the power of x. Okay, you're going to write it down. And then you're going to draw the graph. Then you're going to pick another one. Say you pick -2 to the power of x. You're going to draw the graph. And then you're going to keep going until you have 6 boxes filled up, all with different ones. You can't use the same one more than once. Okay? And then you're going to, when you're done filling in those 6 graphs,